Hello, welcome to Pre-Algebra with Miss Betsy. Today we're beginning Chapter 11 in the text that I'm using, and we're going to begin learning some basic information about geometry. I think you'll find it a welcome break from just fractions and arithmetic. It is, however, going to be lots of vocabulary, lots of new definitions. Once you have internalized all of these geometric concepts, it won't be difficult at all, but it's just sort of like heavy English class for a while. Before we get started though, I've got a new old book that I haven't looked at for a while. My lame jokes were just running out of good sources for them. So here is a joke, a question. It says, what has 12 legs, 6 eyes, 3 tails, and cannot see? Now let's just think about that for a minute. 12 legs, 6 eyes, 3 tails, and can't see. Well, you remember the old song, Three Blind Mice? Section 11.1 is what we're working on right now. This is a very, very brief lesson because it is simply a definitions. If you're using the same text that I am on, we are on page 349, chapter 11, section 1. It's called Basic Geometric Figures. The text that I'm using is Pre-Algebra for Christian Schools, published by Bob Jones University Press. I'm still using the first edition. We have 5 basic geometric figures that we're going to talk about today. The first one is a point, and it's simply a place, an exact location in space. It's simply represented by a dot. Of course, we see the dot because we have to be able to physically look at something, but a point has no dimension. It's just no visible dimension that you can actually see. It's just a point. We're going to identify that by a capital letter. It always has to be a capital letter, and that's just going to be called point A. And I didn't verify that that's actually showing up. Yes, it looks like it's showing up on my screen. The second geometric figure that we're going to talk about is a line. And this looks sort of like our number line, except instead of having numbers identified on it with our little hash marks, a line has 2 points on it. And well, a line has an infinite number of points, but we draw the picture of the line and it looks like something like this. And the way that we're going to use, the symbol that we're going to use for this is just any 2 points on the line, which we have an A and a B here. So if we would say A, B with like a little teeny tiny number line on top of it, this is what we would refer to as line AB. That's how we would read it. This is an example of how we would identify a point, and we would call it point A. See what I'm saying? We're using capital letters, not small letters. We use small algebras, small letters typically to indicate variables. But when we're identifying geometric figures, we're going to use capital letters. Single points, you don't think of that as being a figure, but it is in geometry. A single exact location in space, you use a capital letter. You identify it by saying point A. What a line is, if you look at your text, it says a line is a set of points that extends infinitely in either direction. And you remember that infinite means it just doesn't stop. You know, our number system is infinite because no matter what number you come up with, I can come up with one that's higher. 99 bazillion, quadrillion, googolplex. I have no idea what the newest numbers are. But you come up with the largest number that you can come up to, and I can say, well, let's just add 1 to it. Add 1 to it. So that's what infinite is. It continues on infinitely, this line, in either direction. And you can identify a line by naming any 2 points on it. let's extend this line a little bit and let me show you what I'm talking about. Because a line extends infinitely in either direction, there's no way in this world that you can show all of the points that are on it. So these pictures that we have here, these letters, these are just a few of the points that are represented or that are contained in this line. Now you see I have D, A, B, C, E. They're not in alphabetical order. That's just for my sketching purposes here. Now let's look and see if any 2 points determine a line, meaning that you can define a line simply by using 2 points that are contained on this line with that little number line figure on top of it. Well, you would have line DB. Could be a way to describe this line because you have D and B. You could say line AE. You could say line CE. Could call it line DA. You see what I'm showing you here is if you're going to name a line, you just pick 2 points that straight line goes through, use them as capital letters bumped together, make sure that you put your double-headed arrow on top of those 2 letters, because that's the only thing that indicates to me that you're talking about a line. So if we have the line A, let me see, AC, I ask you to identify a line. You tell me line AC, okay? That's correct. But line AC is not the same as this symbol, but just what you think of as being a line over it, that's not the same. It's not the same as this, where you have an arrowhead on one end of the line. These are not the same. So what am I trying to show you here? This is something where you have to be very specific, very precise in your identification of these geometric figures, because what this actually is right here, this AC, that's what they call it, it's a line. It goes on forever in either direction. This here, without the arrowheads on it, is a line segment. It's just like a little piece of spaghetti, sort of, cut out of a piece of spaghetti that goes on forever. This right here with the arrowhead on only one side is what they call a ray, which we're going to be talking about in just a moment. So we have point A, and we have a line that we've learned how to identify. Now we're going to learn how to identify what they call a plane. And a plane is like a sheet of glass, sheet of paper, the floor, a wall that extends infinitely in all directions. You know, it has no real size to it. You can't see it, but our minds think of it as a sheet of glass that goes on forever, infinitely in all directions. And planes can have many, many different, there are an infinite number of planes that can occur, that pass through any line, because see how my arm is rotating here? You know, you can have a plane going in all of these directions. It's like having a sheet of paper that goes through my arm. So you have many, many, many different orientations of planes, but they are shown with, if you wanted to draw a picture of it, you're going to have 3 points contained in that plane. Doesn't matter what those 3 points are labeled. Might be point A, B, and C. But you put these little arrows to indicate that surface, or that plane, that dimension keeps going out infinitely in every direction. And this plane right here would be identified simply by three of the points that are in here. This would be plane A, B, C. And if you look in your text tells you a plane is a flat surface that extends infinitely in all directions. 3 points that are not on the same line indicate a plane. So let's just put some more points in here. We have point D, and we have point E. Now the points have to not be on the same line to determine a plane. So what are some more examples that we could use of these 5 letters here, these 5 points, to determine or to tell us that we're talking about this plane here? Well, we could say we have ABC. We could say plane ADC. We could say plane ADE. We could say plane BCD. Plane BCE. I'm sorry, plane BCE. Plane CDE. I may have gotten all of them, I'm not at all sure. ABC, ABD, I didn't get ABD. Line ABD, ABE. Did you hear me slip into that line? I'm not going to re-record the video, but planes are indicated with 3 capital letters. You don't have to draw that little square. But these are what planes are indicated by. Now what I said earlier that may have slipped right past you in this definition, let me go back to this. This tells us that 3 points not on the same line determine a plane. So what are those called? Those are 3 non-collinear, and I just spelled that wrong, I think there's 2 L's in there. 3 non-collinear points determine a plane. That little piece of information is very important there. You have to know that the 3 points cannot be on the same line. Why is that? Because if you have 3 points on the same line, like point A, B, C, they're just on the same line. Remember, you have an infinite number of points that are contained on any line, so in order for there to be a sure definition of a plane, you have to have 2 points, of course, that are on a line, and then a 3rd point that is somewhere off the line, and that's what makes it 2 dimensions. You have length and width, okay, like finding area. So far we've talked about planes, which are identified by 3 capital letters, representing 3 points that are 3 non-collinear points. That's how we identify a plane. We've talked about lines. Lines are indicated by 2 capital letters representing points that are on that line with a double-headed arrow above it. And we also have shown how we indicate a point, which is simply an exact location in space, and that's just a single capital letter. Let me re-emphasize that you use capital letters only. You do not use small letters when you're identifying these geometric figures. Now we have 2 more figures that we are talking about, and these are called line segments and rays. So let me go ahead, let's do this number, I'm sorry, I'm so used to doing number line. Let's go ahead and identify this line here. we know that we have a line because there are 2 points that are contained in it. We can call this line AB, line AC, or line BC. Once again, the 2 capital letters with the number line looking figure drawn on top of it, line AB, line AC, and line BC. Now, is it sufficient for me to not put the double-headed arrow above these? No, it's not, because otherwise we don't know what we're talking about. Let me illustrate. This first column, we have lines. The second column, we have line segments. And you say, what column? Well, give me a second and we'll get a second column. Line segments are like having this great big long, maybe you've been to Gatlinburg or to Branson or to Grapevine, someplace where you've seen them making taffy and they've got this machine and it's pulling the taffy, stretching it, stretching it, stretching it, just rotates sort of like this. And then they pull this great big long rope out there of taffy and then the machine chops it up into little pieces. Those little pieces that the machine is chopping that candy up into are what we would refer to in geometry as line segments. You're going to identify those using exactly the same letters that you would to identify lines. But these are line segments. Didn't match my colors very well here, did I? A line segment just has, think of it as like a little piece of spaghetti sticking right on top of it. There's no arrows, and why not? What do the arrows indicate? The arrows indicate that this line continues infinitely in the direction of the arrow. The absence of arrows above 2 capital letters tells us that we simply have a little piece of the line. And this would be read line segment AB. So that right there is really what line segment AB is. That's a picture of AB. A picture of line segment BC would look like that. And what you have with line segments, you have a beginning point and you have an ending point. Here, line segment AC, the line begins, it commences at point A, it ends at point C. And you see where as just a part of our common everyday conversation, we sort of get to get from point A to point B. You go this way, well, that's a specific geometric concept. You start at A, you end at C, that is a line segment. So where would line segment BC be? What would it look like? Well, yeah, you begin at B and you end at C. These are line segments. The final thing that we talk about are rays. And once again, we are going to use the same capital letters to indicate rays. What is different is what the figure is that sits on top of those pairs of letters. A ray has, you shoot the ray gun if you used to watch Marvin the Martian, which you didn't used to watch Marvin the Martian unless you're my age. Maybe you can get reruns of it now. But Marvin the Martian has his ray gun and he's starting at a fixed point. He's shooting that ray gun. And it's going on sort of like forever, theoretically. Ray AB begins at point A and it continues infinitely through point B. So this right here that I have sketched above my number line is a representation, or above my line, is a representation of ray AB. It begins at point A. It has a beginning point, but it doesn't have an ending point. Now, if we're having the line AB and line BA are the same, aren't they? Doesn't matter where you start or where you finish, if you're going on forever on either side. Line segment AB and line segment BA are the same because it doesn't matter. However, with rays, they're not the same. Let me show you what I mean. Ray AB is not identifying the same geometric object as ray BA because the first letter of a ray indicates the point at which that ray begins. So you have ray BA going in an opposite direction from ray AB. Okay? So we have ray AB, we have ray AC, and we have ray BC. Ray AC begins at point A, continues through point C, forever. Ray BC begins at point B, continues through point C on infinitely in that direction. Okay? Those are the definitions that we have from section 1 of chapter 11. Got to get these down in your memory, and then, so we're going to have lots of practice today identifying different planes, different lines, and seeing that if you try and look in your book, your answers may very well be different than answers that you find in your textbook, because you can identify bunches of different lines or rays from a single figure. Let's go ahead and let me do something right here, just real quickly. I'm making a triangle here with the intersection of 3 lines. And I'm going to say that I have point A, point B, and point C. And we're going to talk about this. And let's say that a question is, tell me, look at this figure, tell me a line that passes through point A. Well, a line that passes through point A would be line AB, isn't it? Goes through A, goes through B. Well, what else could it be? Well, there could also be a line passing through point A, but it goes in the opposite direction, well, in a different direction through point C. So right here, 2 answers for this question. What about giving me a line segment that is contained in this figure? Well, AB is a line segment. From B to C is a line segment. A to C is a line segment. You could also even identify these in reverse orders. CA, BA, CA, BA, CB. So you see that we have several different answers that could be given to the question, give me a line passing through point A. Identify some line segments that are in this figure. What about rays? There are lots of rays. You could have the ray BA. What does that mean? The beginning point is B. The ray extends infinitely through A. You can have ray CB, the beginning point. They call it the end point. But it begins at point C, continues through point B. So you have many different possible solutions to these questions. So don't get hung up if you're looking in your teacher's edition and you're not getting the same answers, but make sure that you understand very fully and very completely point, line, plane, segment, and ray. I'll see you next time.